Alright, in the last video, we worked with some, I call them identity puzzles, where you had to take an expression and simplify it down using the trigonometric identities as much as possible. And I also forgot to mention that, if you have a TI-89 calculator like I do, either a titanium or the classic one from the late 90s, or even a 92 or a Voyager, or some other fancy computer algebra system, if you put in an expression like this, it will simplify it down into the lowest terms, but only using sines and cosines. So previously, I put it in an annotation after I uploaded it, but previously the answer would have been acceptable as sine squared over cosine cubed. So here we're just going to simplify this down as much as possible in terms of sines and cosines. So, let's work with this one first. It looks really daunting, kind of. Cosine squared of theta times cosecant to the fourth of theta all over the quantity 1 minus sine squared and that squared. So again, what pops out? Well, this kind of looks familiar, so I'll just write down the basic Pythagorean identity down again. It's sine squared of theta plus the cosine squared of theta equals 1. And you can subtract sines from both sides. It's going to be 1 minus sine squared. And it's going to be cosine squared of theta is equal to 1 minus sine squared of theta. So we can just put the cosine in place of that. So let me erase that so we have some room. So now that's a cosine squared. So it's a cosine squared of theta times a cosecant raised to the fourth of theta. Cosine squared of theta. Whoa, I forgot an S. Cosine squared of theta squared. And it's just basically cosine squared times cosine squared. Combined powers, that's cosine to the fourth. So that's cosine squared of theta times cosecant to the fourth of theta all over cosine to the fourth theta. Now, here, you could do some reduction here with powers. This will cancel, two of these cosines will cancel with 2 down here. So this is gone, and this becomes a cosine squared. So we're left with cosecant to the fourth over a cosine squared. And you can change this cosecant into 1 over the sine. So that's 1 over sine to the fourth of theta. And that's divided by a cosine squared, which is multiplying by a cosine. It's multiplying by 1 over a cosine squared. So it's going to be 1 over cosine squared of theta. I guess that's as far as we can go with this one, because there's no other identities that we know that are products. Nothing else can really help, and we want it in terms of sines and cosines, so this works. Now this next one, it looks kind of easy, and it kind of is. 2 times the secant of theta times the sine squared of theta all over the cotangent squared of theta. The first thing we want to do, does anything pop out? Not immediately. Nothing immediately pops out. But I can take this part right here, the sine squared over this cotangent squared, and break it off, because it's multiplication. So it's 2 times the secant of theta times sine squared of theta over the cotangent squared of theta. Next thing I want to do is turn this into multiplication. So that's sine squared times 1 over the cotangent, which is sine times tangent. So that's 2 secant. And actually, let me put that secant as 1 over the cosine. You may see something. Actually, let me write that as 2 over cosine. 2 over cosine of theta times sine of theta over cosine theta. Oh, those should be squares. Times sine squared of theta. Nothing else really cancels, so this is, we just multiply across, gives us 2 sine to the fourth of theta over cosine cubed. And we usually want it in terms of sines and cosines. A calculator would give you this, and that's correct. I also want to take some time to introduce you to some trigonometric equations. So let me erase this right hand side. A trigonometric equation is an equation that has you solving for angle values that satisfy a certain equation. That's what they usually are. And usually you'll be working in an interval of one period. You'll usually be working in the interval from 0 to 2 pi, meaning everything between here, including 0 but not including 2 pi. So an example of a trigonometric equation would be, I don't know, 2 cosine squared of theta plus 4 cosine of theta plus 2 equals 0. And what we want to do is solve this for all possible values of theta that fall under that interval. So what we would have to do is just manipulate it, work it as a general equation, and then we get an answer. Or a set of answers. You also have to watch out if you're dealing with tangents. Remember, if you're dealing with tangents, if you're dealing with cotangents, secants, and cosecants, remember that there are some values where these functions are undefined, so be careful there. Remember not to get any extraneous answers. In the next video, we'll work about one or two of them, and then you might be on your way with Trig.